Hello everyone, welcome back to another Mr. Cuban lecture. This afternoon I want to talk about Lewis structures. So Gilbert Newton Lewis was this guy who came up with models. And there's a bunch of different models for how things should kind of be put together. All right, and these get really confusing for students. There's a few things you need to keep in mind when you're making a proper Lewis structure. The first thing is to find the central atom. Find the central atom. Okay, and as a caveat, it's almost always going to be the one on the left. Okay, so if it's NH3, it's the one on the left. If it's CO2, it's the one on the left. Okay, there's a few weird exceptions to this. If somebody were to ask you to say CH3COOH, this one confuses a lot of people because they're like, well, that's carbon's the central atom, and kind of in a way it is. Whenever you have carbon that's present, carbon's going to be bonded to carbon usually. Okay, so as a caveat to this, do carbon to carbon if you can. All right, that's something to remember. Carbon always bonds to carbon. Not always. All right, there's a bunch of weird exceptions. The thing about it is that by the time you get good at these, they get really easy. Okay, the second thing to remember here, all right, these are covalent bonds, right? So in order for two things to connect to each other, they have to have at least one bond. Okay, now it's an ionic structure that's a little different, but we're going to ignore that. These are all covalent. These are sharing electrons. All right, so okay, one bond at least. All right, this is important to remember. One bond at least. Okay, now this is, and then there's some other things you need to do. Always. This is very important. This is where students make their big mistakes. Count your electrons. So let's take SO4 2 minus, one of the most complicated Lewis structures you can draw that's got a central atom. Okay, SO4 2 minus. Okay, and when I say count your electrons, I only mean valence electrons, because these are the electrons that bond, the ones on the outside of the shell. So when you get your periodic table, right, you find sulfur. Sulfur is here. It's below oxygen. You count. You go 1, 2, 3, 4, 5, 6. Sulfur has 6 electrons. Oxygen also has 1, 2, 3, 4, 5, 6 electrons. Okay, so we're going to 6 plus 6 times 4. And then here's where you have to be careful with electrons, because you count them backwards. Because remember, electrons are negative, so if it's 2 minus charge, that means you have 2 more electrons. Okay, if it's 2 positive, you take 2 away. So in this case, plus 2 electrons. So I have 24 plus 6 is 30 plus 2 equals 32 electrons. All right, so count your electrons. And then the other final point here I want to make, try for the Oct, right? It's the 10th month because of Julius Caesar and Augustus Caesar came in and made our year 12 months instead of 10 months because they're ridiculous, because they had their own empire and they had their own things they wanted to do. Anyway, so Oct actually means 8, which you know is because of octopus, right? It's got 8 legs, octopus. October should be the 8th month, but side issue, you can check out the history on that if you want. Octet rule. And this means that in general, atoms want 8 electrons. All right, and now actually I'm going to go over SO4 2 minus here because this is a perfect example of the exceptions to the rule. I'm going to go over the basics of a Lewis structure, and then I'm going to make it a little bit harder because there's a better answer. right? We're always trying to improve the model to make it better. So if we draw our central atom, which in this case it's on the left, it's going to be sulfur, right? So we'll have sulfur here. And then the thing about these oxygens is they go around the sulfur, okay? So I'm going to have an oxygen here. And keep in mind, one bond at least, okay? So we're going to have one oxygen there, one oxygen there, one oxygen there. Now, we need to show our lone pair electrons. These are the electrons that are left over, okay? So in this case, if I just fill in the electrons, okay, so I'm going to have 1, 2, 3, 4, 5, 6. Now I have 1, 2, 3, 4, 5, 6, 7, 8. Now in bonding for Lewis structures, these two electrons count for both to help satisfy the octet rule. Let me say that again. These electrons that are to bond help to satisfy the octet rule to give this oxygen 8 electrons. In redox chemistry, this is very different, but we're going to ignore that until you do redox chemistry, which is a totally separate thing. Okay, so I'm going to do this again. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So all the oxygens have 8 electrons, and the sulfur actually has 1, 2, 3, 4, 5, 6, 7, 8. All right. So then, here's where I have to, so this is actually a correct Lewis structure for sulfate. You look online, you look up SO4 2-, you will find this structure, okay? But you're gonna find a couple others. You're like, why do I have a couple other structures? What are these other structures for? And here's where things get a little bit different, okay? And this is rule number 5. And this is a very weird rule, and this is where students get lost and confused, because most people can do this, all right? You get 8, you have bonds, and actually, I didn't even count 32, because I just remembered this 32, right? Because I have 8, 16, 24, 32. I have all my electrons. Okay, rule number 5. Try to minimize, and minimize means to make smaller formal charges. So you might be asking yourself, what the heck is a formal charge? I don't know what that is. And in your answer to your question, a lot of people don't, but if you go to college and you take biochemistry or organic chemistry, these become very, very important. Think about it this way, all right? You can hold a book, right, or a bottle on it, because you got 2 arms, okay? Can you hold a book and some tissue? Can you hold a book and some tissue and some cards? Right, there gets a point where your hands get full. The same thing with atoms, okay? All of these oxygens here, instead of having 6 valence electrons, which they usually would, they now have 8, but they're not really all theirs, okay? So what you do for the formal charge is you find out how many additional electrons they have over their normal number or below their usual number. Okay, so formal charge, which I'm just going to call FC, formal charge is equal to number of normal valence electrons minus lone pair electrons. And the idea here is that these 6 electrons around oxygen are not being shared with sulfur at all. Okay, they are oxygens, okay? This is like you have money in your pocket, it belongs to you. You get married to somebody, you form a strong covalent bond. Some of that money when you get married is yours. Some of that money belongs to both of you, okay? But in this case, this is the money, these are the electrons that just belong to you. So minus lone pair electrons. And then, this is where your bond comes in. So half of these electrons, and this is not true in redox, this is only true in Lewis structures, for formal charges belong to this oxygen, minus number of bonds. And sometimes you'll see this written minus bonds, a number of electrons at a bond times 1/2, because half the bond belongs. I just do number of bonds because it's the same calculation, it's easier to think about, okay? So oxygen in this case, so my formal charge on oxygen is going to equal 6, which is the normal number of valence electrons for oxygen, minus, how many does it have right now? It has 1, 2, 3, 4, I'll try and make this clearer for the video, 5, 6. So 6 minus how many bonds does it have? It has 1. And that equals -1. And what this means is that this oxygen has a -1 formal charge. Now, a -1 formal charge for oxygen is no big deal because it's electronegative. Well, sort of, but it doesn't really want it. It wants like a quarter of a negative charge. It doesn't want a full extra negative charge. That's a lot. Okay? And this oxygen, you notice, is the exact same because they all have 1, 2, 3, 4, 5, 6 electrons and 1 bond. So they're all the exact same. So the oxygens are all -1, -1, -1. I'm sorry, that's not there. And -1. Okay. So you might be sitting there thinking to yourself, oh my god, all the oxygens are negative. And in answer to that, yeah, that's true. They're all negative. And that's not the best thing for oxygen to be. Okay, so how can you fix this? Well, let's look at sulfur now. Okay, so sulfur is going to equal, remember it has 6 valence electrons. Usually we count it, when you count the electrons, you figure this out. Minus, and what is sulfur? Sulfur is in 4 bad marriages at the moment. It doesn't get anything to itself. It doesn't have its apartment, doesn't have its house, it's nothing. So minus 0. Minus, how many bonds does it have? 1, 2, 3, 4, because half of these bonds belong in it. If it's a divorce in chemical divorce court, it's going to get 4 electrons. So it has a charge of +2. Is anybody happy? No. Sulfur is positive. Oxygen's negative. So what you can do, and this is where you have to really try through, is there's this thing called resonance. Okay? And I'm not going to do resonance today because that'd take too long and I'm running a board space. I'll go to resonance on a different lecture. But what I'm talking about here is these electrons can move down. So before where you had a single bond, you can actually form a double bond. And so what happens with sulfur and sulfate, and I'll draw this down here, so you actually get sulfur, and it's got 2 double bonds to oxygen, and then a single bond to this oxygen, and a single bond to this oxygen. And I'm going to use this later on when I talk about resonance, okay? Because these oxygens are negative, that's true. And this oxygen, it's going to have the same formal charge up here, -1. But these oxygens and this sulfur, if I like oxygen here, for this oxygen, it's going to be oxygen is going to equal 6 minus 1, 2, 3, 4, minus 2 equals 0. And that oxygen is going to be the exact same. And you notice there's 32 electrons here. There's also 32 electrons here. So the same number of electrons. I did not violate any previous rule. The rules are the same. This sulfur is going to equal 6 minus 0 minus 6. And it's going to be 0 too. So my total number of formal charges went from 1, 2, 3, 4, 5, 6. 6 formal charges, boo, to 1, 2. 2 formal charges. Ding, 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 ding. That is the winner. That's what you want. You want 2 formal charges. Okay, so when you're drawing Lewis structures, you gotta remember there's always gonna be 1 bond. There can be as many as 3 bonds. Okay, so an example of that would be carbon with a hydrogen here, and then a triple bond to another carbon and a hydrogen. Okay, that's possible. You can have 3 bonds. And the reason for that is the s orbitals line up across the plane and give what's called a sigma bond. That's the single bond. And then the pi orbitals that go above and below the axis, so there's on the y-axis, they share. Okay, and then on the z-axis into the plane, they can share their electron density. And those are called pi bonds. It's the double bond and the triple bond is a pi bond. The problem is the pz axis, where they face each other, can't go where the s orbitals are bonding, so they can't bond. They have to bond outside of the sphere. And that's why carbon has a bond with this hydrogen and this carbon is with this hydrogen. Okay, you can't have 4 bonds, you can only have 3. If you have any more questions on Lewis structures, please put them below. I'll go into resonance and a few more specific examples in a later video, but this is a good solid introduction to Lewis structures with the 5 main rules. There are 1. Find the central atom. Rule number 2, 1 bond at least. Everything has to have a bond or it's not a Lewis structure. Not a bond. They're not connected to each other. There's not sharing anything. Rule number 3, always count your electrons. Rule number 4, try for the octet rule. All right, now you notice the sulfur here actually has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It has 12 electrons in its valence shell. What? That's because anything that's in row 3 or below, and this has d orbitals, so they can actually go above 8 electrons. All right, a few of the elements, boron, aluminum, beryllium, they can actually get 6 or 12. So the octet rule is more of a general nudge, but try for it. That's why I said try. I didn't say you have to get the octet rule. The other thing was try to minimize formal charges. Because as far as Lewis structures are concerned, this is actually a good Lewis structure. This is a model that works, it follows all the rules. But this is a better picture, and this comes into handy later when you're trying to talk about acid-base chemistry and what's a stronger acid, what's a stronger base, and that has to do with formal charge on each atom. And that has to do with resonance structures, which I'll talk about in a later video. Anyways, thank you for your time. I wish you guys have a good day, and if you have any questions, please comment below. Thank you.